So here we have a list of data where we're looking at test scores, and I've arranged the data from smallest to largest. If we want to find the range, we subtract the highest and the lowest data values. So in this case, we would subtract 72 from 100, and that would give us the range of 28. The mean is the average, so we add up all the data and divide by however many data values we have in the sample. And in this example, there were 10 test scores, so we're going to divide by 10. So we add up all the data values, the 72 plus 76 and 78, so forth and so on. We get 856 and then divide by 10 to get a mean of 85 and 6/10. The mode is the data value that data entry that occurs most often, and so 88 occurred twice in our data set. So 88 is the mode. And now we want to find the median, which is the middle. I use a method to find the middle of the data, which I call just the counting off method. So if we come back to the original data set, let me switch over. We want to find the middle. We just make sure the data is ordered chronologically, and we cross off from the outer ends of the data and work our way to the middle. So I would cross off 72, and 100. Cross off 76 and 94. Cross off 77 and 92. Cross off 78 and 91. And so we're left with two values. We can't cross those off because we cross them off, we have nothing left. So we're left with these two values, and we need to add them and then divide by 2. Of course, that's going to give us a middle value or a median of 88. But sometimes those two numbers that we're left with are different numbers, so be sure to add them and divide by 2 to find the median. The next thing that we want to talk about is how to find the mid-range. We found the range, which was the high minus the low, but the mid-range takes the highest value and adds it to the lowest, then divides by 2. So that would be our 100 plus 72 divided by 2. And that's how you find the mid-range. So the mid-range would be 86. Okay, and that is all for this section. I want to scroll back and go back to the beginning where I thought I was recording and it was actually recording nothing, and talk about this frequency distribution. I made a frequency distribution here with the test scores with where we just made tallies. Okay. And then we add all the frequencies to make sure we had 10 data values to make sure we didn't miss anything. The next thing that I thought I was recording but wasn't was I made a histogram that had a class width of 1, and then I turned it into a frequency polygon. So a frequency polygon and a histogram are related in that you make the histogram. So the histogram is like a bar chart except it's showing quantitative data. And so 72 occurred one time, 76 occurred one time, 77 occurred once, 78 occurred once, 88 occurred twice, so forth and so on. So this histogram is pretty flat because the data values only occurred one time. Okay, and then to make the frequency polygon, we put a dot in the middle of the bar for each one of these data values and then connect the dots. That's all. That's what a frequency polygon is. We can change the shape of a frequency distribution or how it looks if we change the class width size. So originally the class width was 1. Well, now here in this frequency distribution, this histogram, excuse me, I've made the class width 10. So I've grouped the data. So there were 4 test scores between 72 and 81. If we go back to the original list, we had 72, 76, 77, and 78. So that's 4. And that's why the bar for this group of data, 72 to 81, went up to 4. 82 to 91, there were 3. And then 92 to 101, there are also 3. So if we were to make a frequency polygon for this data, same data, but from this distribution with the class width being changed to 10, put a dot in the middle of the histogram, connect the dots, and then erase the histogram. So let me see if I can erase this histogram without erasing everything. All right, let's do one more example. All right, so that's what a frequency polygon could look like. All right, let's do another example where we're looking at some data. This data, let's make it short. 5, 10, 15, 20, 25, okay? And we want to find the range. The range is the high minus low, or the max minus the min. So it's 25 minus 5, so the range is 20. The mean is the average. Add up all the data, so 5 plus 10 plus 15 plus 20 plus 25, and then divide by the number of data values, number in your sample size, how many data points you have. We had 5 of them. So 5 plus 10 plus 15 plus 20 plus 25 is 75. Divided by 5, so the average is 15. We want to find the mode, what data value, if any, occurs most often, and each one of these occur one time, so there is no mode. We want to find the median, which is the middle, and so we have 5, 10, 15, 20, 25. I think that's where we stop. Yeah, so we want to find the middle, start from either end, cross off the data value with its pair on the other end, or matched pair, so 5 minus 20, 5 gets crossed off, 25 gets crossed off. 10 gets crossed off, 20 gets crossed off, which leaves 15 as the median. And let's see, do we want to do quartiles? Did they ask for quartiles in this section? I don't see any mention of the quartiles. I'll just say that the median is the second quartile, which is the 50th percentile, because it's the halfway mark, half of 100%, so halfway mark. The first quartile is the 25th percentile, or the 25% mark, and the third quartile is the 75%. So think of it like quarters. 3 quarters make 75 cents. Same thing with quartiles when you're talking about making a box and whisker plot, which you are not responsible for doing. So this is my spiel on it. Please also take a look at the other videos that are posted in Moodle.